Hi class, I'm recording a math review to help you better understand the statics. So in today's first math review, we will discuss the units, scalar, vectors, vector additions, and also law of sine, cosine, 3D vectors, and right-hand rules, vector direction, prediction vector, and force vector along the line. So I believe you all should already learn these terms in some class before. If you feel you are very confident about these terms, just feel free to skip this video. But in other words, if you are not confident and not very familiar with these terms, so here should be a very good video to refresh your memory to get you ready for the statics. So, well, with not further delay, let's get started. So, my first slide shows the units will be used for this class. So, what units are used to measure length? So we usually use a meter, centimeter, feet, and inch. And for the time, we usually use the seconds and minutes. And for the mass, we use a kilogram and gram. And for the force, we measure it in laps, Newton, kilonewton. Okay. And one more question. 1 kilonewton equals to how many newtons? So the answer should be 1,000. Okay. And similar, 1 kilogram equals to how many gram? It should be 1,000 as well. Okay. So second term is scalar. So what are scalars? Can you give me some example, like what's a scalar, before I give you more informations? Okay, so scalar is some unit or some quantity which is specified by magnitude only. Okay, so in other words, like the mass, like the length, the kilogram, and the meter, they are measured with magnitude only. So which means those factors or those features, they are scalars. So what about vectors? So vector means some variables has both magnitude and directions. Okay, so for example, the force, okay, the force is definitely a vector which will be used heavily for this class. So for example, let me draw force. Okay, let's see, it's a 6 Newton, and the angle between this vector and the horizontal line is 45 degrees. Okay, so what if I have another force which is 6 Newton? Its angle with the horizontal line is 60 degrees. So if it is a scalar, we would say 6 will be always equal to 6, but the force is a vector. So where the first vector equals to the second vector, even their magnitude are all 6 Newton. So the answer is absolutely no, because the vector, if you want to say one vector is equal to another vector, it has to make sure your magnitude and direction of the both vector is equals. So in this case, their magnitude equals to each other, but direction definitely no. So just pay attention to the vectors. So my next slide, okay, what's the vector addition? So as we mentioned before, vector has both directions and magnitude. So we can not let a scalar, we can just add a plus b, we can get addition very easily. But for the vector, when we are doing addition, we have to consider the directions. So for example, we have vector a and vector b. Okay. And again, here is just a refresh of your memory of your previous mathematics knowledge. So I believe most of you, or all of you, had learned the parallelogram law in your previous classes. So how parallelogram law works? So that's a law we need to use for the vector addition. So for example, we want to get what's addition of vector A and vector B. Okay. So to finish a parallelogram law, let's draw a vector B which is parallel to the vector B, and also draw another vector which is parallel to vector A. So here, with this 4 vector, we got a parallelogram. So the addition means if we want to calculate the addition of vector A and B, we just draw from the parallel diagonal. So the new vector will be the addition of the vector A and B. Okay, that's how the parallelogram law works. We call this resultant, okay, which equals to A plus B. So besides parallelogram law, we also have the triangle law. I believe you already heard it somewhere else. Triangle method. So it is. We also call this tip to tail method to calculate the addition of two vectors. So again, we also calculate what's the addition of vector A and B. So we just draw the vector A here, vector B here. So the way we are doing triangle method is we need to draw the second vector to its tail. So the tip of the first vector is the location of the tail of the second vector. So we draw the two vectors in the tip to tail method, and the addition will be the third line of the triangle there. So the R equals to A plus B, which is the same answer from parallelogram law. Okay. So let's move forward. What's the law of the sine and law of the cosine? So law of the sine for, let's say for any triangular, let's draw a triangular here. A, B, C, and we have A, B, C. So the small letter represents the length for each line of the length, and also the big capital letter represents the angle of the for each of the triangular. So the law of the sine will be A over sine A equals to B over sine B equals to C over sine C. So that's the law of the sine. And also you can also find these equations in your FE package. Okay, in your FE package. So, and what about law of cosine? And for the law of cosine, we have three equations. A squared equals to B squared plus C squared minus 2BC times by cosine A. So that's the first equation. And similar, B squared equals to A squared plus C squared minus 2AC times cosine B. And the C squared will be equals to A squared plus B squared minus 2AB cosine C. Okay, that's the law of the sine and cosine. So let's talk about 3D vector. So before we talk about 3D vector, let's talk about the unit vector, okay? So for vector A, it's a 3D vector. We express it in 1i plus 2g minus 2k laps. Okay. And also the magnitude of A, we put it here, it will be one lap square plus 2 lap square plus minus 2 lap square, which equals to 3 laps. Okay, that's how we calculate the magnitude of this 3D vector. And we have another concept is unique vector of A. It will be each component over magnitude. So for example here, it will be ax over a's magnitude I plus ay over a times g plus az over a magnitude and k. So it will be 1 over 3i plus 2 over 3g minus 2 over 3k. Okay, and now why we call this vector as a unit vector? Because the magnitude of unique vector, okay, equals to 1. And then, okay, let's talk about the right-hand rule. For this class, we use the right-hand rule for the 3D coordinates. For the 3D axis system, so we have z, which is to the upside, and also we have another 2 axes. But how we determine which one is x, which one is y? So just use your right hand. Please use your right hand. Use your thumb towards the direction of your z-axis and curve your finger. So the first axis your finger touch is x, and the second is y. Okay. So in this way, this is x, this is y, and also we use a Cartesian system. Means the I equals to x direction, j represents y's direction, and the k is z direction. Okay, let's draw. This is I, this is j, and this will be k. Okay. So what's a vector direction? So we use alpha, beta, and gamma to represent the direction of one vector. Okay, because it's 3D vector, we need 3 angles to measure its direction. So alpha is for the vector angle with x axis, and beta is for y axis, and gamma is for z axis. And then the range is from 0 to 108 degree. and also cosine alpha, cosine beta, cosine gamma. We can use the cosine angle to calculate we can use the cosine. In other words, if we are given a cosine value, and we should be able to find its vectors angles. So what's a position vector? So position vector is used to locate a point in a space, okay, which is related to another. Let's say we have a 3D axis. In a 3D space, we have x, y, z, and we have A point, B point. How to measure the relationship between vector A and B? And let's say so the coordinate for A and B point is given. What's RAB will be the position vector, okay, from A to B. It will be -2 minus 1. It will be bx minus ax, and 2 minus -3 plus 2 minus 2k meters. Okay, it will be, the answer will be -3 I plus 5g plus 2k meter. And I have a question. Here is answer for vector direct position vector from B to A to B, and what will be the position vector from B to A? Okay, you can do this by yourself.